All right, now we're on to lesson 1.2, which is all about slope-intercept form of linear equations. Now we talked about that a little bit in our last video, so this should be mainly review. Key terms for this lesson is slope-intercept form. And this just means that it is a linear equation that's in the form y equals mx plus b. Now, one thing to note, y and x should always just say y and x. This m and b are going to be actual numbers. Okay, whatever number is right here in front of the x, we call that our m. It's known as our slope. Whatever number goes right here, we call that b, which is the y-intercept. So as an example, we can have this equation. I want you to write this down as an example. Y equals 1/3 x plus 2. Now, as long as it's written in this form, we know that 1/3 is going to be the slope, and positive 2 is going to be the y-intercept. Remember from last video, what does that mean? It means that going from point to point on our line, we're going up 1 over 3, slope of 1/3, and we're starting on the y-axis at positive 2. Okay, so this form of the equation is going to be very helpful. Now, for our first example, we're going to write the slope-intercept form of the equation, given that we know our slope is negative 2/3 and our y-intercept is negative 2. And we have a pretty sweet baby here. Nice. So this slope of negative 2/3 is going to be in place of the blue right here in front of the x. It takes our place of m in mx plus b. Our y-intercept is negative 2. That goes in place of b. So plugging everything in, it should look something like this. Y equals negative 2/3 x plus a negative 2. Instead of saying plus negative 2, you can also just say minus 2. Either one of these is correct, as long as it's a negative here and a negative or a minus right here. Going on to our next examples, we're going to write the slope-intercept form of the equation for each of these lines. Now, one thing that's going to help with these is to first find the slope and the intercept. The easiest of these is going to be to find the intercept. It's always going to be right on the y-axis. I'm going to do it for the other one as well, there and there. Now to find slope, we just find another spot on this line where it crosses on the grid. So this one crosses here, 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 here. Looks like pretty much every one time over, or should I say one time down. So going from this dot to this dot, or even going from this dot to this dot, we're going down 1 and over 1. This means that our slope, our m value, is down 1 over 1. I'm going to write it off on the side here like this. Slope is down 1 to the right 1. Okay, right here I wrote it simplified. Negative 1 over 1 is just 1. But we got it by doing negative 1 over 1 because it's down 1 and to the right 1. That's where this one came from. Now right here, the line crosses the up and down axis, the y-axis, at negative 2. So our y-intercept is negative 2. We call that b. b equals negative 2. Now we just take those values and plug them into the equation. Y equals mx plus b. Y equals mx plus b. Simplify it out a little bit, and we call it y equals negative x minus 2. This would be the slope-intercept form of this line. For example 3, we already plotted out. This would be the y-intercept right on 0. Now the next place it doesn't cross here or here. These all look pretty close. It looks like here is the first time it actually crosses right on the grid, and right here. So going from this dot to this dot, we're going up 1, 2, 3, 4, 5, and over 1, 2, 3. Same thing, 1, 2, 3, 4, 5, 1, 2, 3. So we're going up 5, our m value, up 5 over 3. which means our m value is 5/3, our b value is 0, because it crossed this y-axis right here at 0. Plugging those in, the blue m, the green b, into y equals mx plus b, y equals 5/3 x plus 0. We can simplify that to just y equals 5/3 x. So that would be how to write an equation given the line. Okay, you'll have to first find the slope and the y-intercept, plug them in. Graphing equations. So there's the slope-intercept method of graphing, which again, is kind of going backwards from here. You find your y-intercept, you plot it on there, you use the slope, and you move over from there. So plot the y-intercept, use the slope as your rise over run to find the next point. So from your y-intercept, you go up or down, however many you're supposed to, and then over to the right, however many you're supposed to. Okay, with those 2 points then, just simply connect them with the line, and you have your linear graph. There are 2 special cases, horizontal and vertical lines. Horizontal lines, they are the ones that run left and right, like the horizon, horizontal. They only contain the variable y, so no x. So the general form is the y equals a number. So like y equals 5. This makes a horizontal line, and their slope is 0 because they are not going up at all, and they're going over as much as you want. So it would look something like this. 0 over any number you want. Let's call it 10. 0 over 10 is still 0, so they have a slope of 0. Vertical lines, on the other hand, run up and down. They only contain the variable x. There's no y in the equation. The general form is x equals some number, so like x equals -2, and their slope is what we call undefined. Here's why. As they move, let's say, I want to make a graph of it really quick. Here's my axes, and it's a vertical line, so it looks something like this, moving vertically. Let's say I picked 2 points, this point here and this point here. Using the slope as rise over run, this going from here to here, we'll say that's rising 3 points. The run, the left and right, is 0. It's not moving left or right at all. So its slope is 3 over 0, or 3 divided by 0. Now we can't divide by 0. That doesn't work. So we would say it's undefined. Undefined. The slope does not exist. We can't have a slope of a vertical line. So, going on to these examples, for each equation, identify the slope and y-intercept first, then sketch the graph of each line using that slope-intercept method. So we did this a little bit in our last video as a way to double check. So this should go nice and easy. Y equals -4/3 x minus 3. This number in front of x is our slope, -4/3. This number behind it with no variable is our y-intercept. Because it's a minus, we consider it negative. So -3. Slope is -4/3. Y-intercept is -3. Y-intercept tells us to start at -1, -2, -3, right here. This slope of -4/3 is telling us go down 4, 1, 2, 3, 4, and over 3. 1, 2, 3. We connect these with a line. I'm just going to use a regular line like this, and then I'm going to extend it like that. Notice, reading from left to right, because we always read left to right, it looks like this line is going down. You'll know that it goes down because it has a negative slope. Negative slope, going down. If it was positive, it should be moving up. So that's a way to check and make sure that your down so many and over so many makes sense. Negative slope, going down. So, on to example 5 then. We have y equals 3x minus 1. Again, slope is in front of x, so it's 3. y-intercept is behind it. It's our b value. Again, because it's minus 1, we call it a negative 1. So using our slope and our y-intercept, negative 1 tells us go right here. Positive 3 tells us so we're supposed to go, well, let's, if it helps, convert it. Instead of 3, we'll call it 3 over 1. Because 3 is the same as 3 over 1. That tells us go up 3, 1, 2, 3, and over 1. So there's the next spot. Now if it helps, we can make a couple more points. So 1, 2, 3, over 1, 1, 2, 3, over 1. That might help us in making our line. Have a couple extra points. It'll go like that. So this is going to be our line for y equals 3x minus 1. A couple more examples here. Y equals negative 5. Remember, this was one of our special cases. So technically, if you wanted it in slope-intercept form, it would look like this. Y equals 0x plus negative 5. In which case our slope is 0, just like that. Our y-intercept is negative 5, just like that. Which tells us we start right here, and we don't go up any, we just go over 1, over 1, over 1. We're never going up, we're just moving over. Same thing in the other direction. We're not going up, we're just going over. So as we connect those, it makes a horizontal line. Y equals negative 5, horizontal line at negative 5. This is the other special case. This is x equals. On x equals 3, remember there is an undefined slope because it's not moving over at all. It's just moving up. So it'd be like dividing by 0, which we can't do. The y-intercept, well, it never crosses this line. So we would say DNE for does not exist. There is no y-intercept. It never crosses there. But it will have these points anywhere where x is 3, so right here, or right here, or right here. All of these points count. And we can connect those with a vertical line, like so. And that is the graph of x equals 3. And that'll be it for our second video.